Hi, I am Sanath from the Technology Innovation Institute UAE, and today I will be presenting our work, Do VSR Models Generalize Beyond LRS3? This is a joint work with Yasser, Eustache, Haithem, Ebtesam, and Merouane. Decoding what a person is saying from a silent video is called visual speech recognition. Existing approaches, both supervised and self-supervised, train on thousands of hours of lip sequences. However, they evaluate on video clips totaling only 1 hour duration, which is typically from the LRS3 test set. In order to overcome the overfitting problems, we propose a new VSR test set which incorporates higher visual diversity and spoken vocabulary. We call this test set Wild VSR. We also introduce a new metric, rank WER, that better captures a model's confidence. Finally, we benchmark existing approaches on the new test set and also do a performance versus compute analysis to see how each of these models fare when comparing the performance in the performance versus compute trade-off. For building the Wild VSR, we first utilize the YouTube search API to target relevant English videos that have been published under a Creative Commons license, and we capture these by having a list of 21 keywords. These keywords include interview, discussion, talks, etc. Next, we closely follow the LRS3 creation process. For each video, we first do a scene change detection to get a number of scenes in the video, and then proceed with capturing or detecting the faces in each of these scenes using a YOLO V5 face detector. Then these the detected faces are tracked, and a SyncNet-based active speaker detection is used to isolate the main speaker and to get multiple face tracks from each video. Next, we use a Whisper ASR model to discard the non-English clips and then obtain pseudo transcripts. Whisper is also used to segment the tracks into shorter clips using the word timestamps predicted. Finally, we manually verify the transcripts and obtain lip sequences text pairs for our Wild VSR test set. Our proposed Wild VSR test set has higher number of utterances, almost 1.5 times unique speakers, 4.6 times the word instances, and three times the vocabulary coverage, along with 5.3 times the duration in comparison to the existing LRS3 test set. In terms of gender diversity, we are relatively better while being marginally better in terms of race. Benchmarking the existing approaches, we see that most of the approaches, all the approaches generally perform better on LRS3 in comparison to our proposed Wild VSR test set. This observation holds in terms of in WER as well as our new rank WER metric. This suggests that our Wild VSR test set is much more diverse and has harder samples, which are required to understand the model's capability in decoding text from a silent video compared to LRS3. Next, we look at the performance versus compute trade-off for the existing approaches. we see that supervised models, and specifically auto VSR, demonstrates a very good balance between performance and compute budget. However, this is not the case for self-supervised methods such as Hubert and Raven, which require a significantly higher compute budget while they achieve a moderate performance in terms of WER. This suggests that self-supervised methods are less in or are inferior compared to supervised models for the VSR task. Next, we look at the representation variability of different encoders such as Raven and Auto VSR for our LRS3 test set and wild VSR test videos. So we do a Tucker decomposition of encoder representations on sample videos from LRS3 and wild VSR test sets and compare these representations for different models. We see that for LRS videos, the models are generally able to capture the underlying modes and patterns in the input signals. This enables accurate generation of precise transcripts at the decoding stage. However, fewer modes are detected for the wild VSR videos, and this in turn leads to suboptimal text decoding. This suggests that while models are able to capture the modes and the patterns easily in LRS3 videos, our wild VSR test set has higher diversity and more hard samples, like videos with non-frontal head poses, etc., which makes the patterns, detecting the patterns harder, and thereby having a lower performance or a higher WER score. Thank you. We release our dataset at the following link. Please visit our poster for more technical discussion and results and analysis.